Good afternoon guys, my name is Sajal Miriam Verbo and I am here to discuss the ancient ideas of matter. First one is the atom is proposed. A few decades after Empedocles Democritus, who is also a Greek, developed a new theory of matter that attempted to overcome the problem of his predecessor. Democritus' idea is based on reasoning rather than science, and drew of teaching of two Greek philosophers who came before him, Leucippus and Anaxagoras. Democritus knew that if you cut a stone into smaller pieces, at some point it will be tiny that you cannot see it. Democritus called it infinite small pieces of matter, atomos, or indivisible. He suggests that atomos are eternal and could not be destroyed. Aristotle accepted this theory but added his own, and it is wrong. Aristotle and Plato are known to be the best philosophers, but they declined Democritus' theory, in which air and other gases have small particles that are too small to be seen. Empedocles' theory was quite popular, but it had a number of problems. For example, regardless of how many times you break a stone in half, the pieces never reassemble any of the core elements of fire, air, water, or earth. Despite this problem, Empedocles' theory was an important development in scientific thinking because it was among the first to suggest that some substance that looked like pure materials, like stone, were actually made up of combination of different elements. Mass. Scientists were busy studying the natural world at this time. Shortly after Bernoulli proposed his theory, the Englishman Joseph Priestley began to experiment with the red mercury calx in 1773. Mercury calx, a red solid stone, had been known and coveted for thousands of years because when it is heated, it appears to turn into mercury, a silver liquid metal. Priestley had observed that it does not just turn into mercury, it actually turns into liquid mercury and a strange gas. Priestley carefully collected this gas in a glass of jar.
Hi, I'm Ruby May Enriquez from M12I and I am going to discuss about the inside of the atom. Imagine this is a pool ball. The black circle you can see is the electron, which is the negative charge particle and is located at the electron cloud. The peach color circle is the nucleus, which has proton and neutron. The proton is the positive charge particle and the neutron is the neutral charge, which is slightly heavier than the proton. And this is all the parts of an atom.
Hi, I'm Yaka Sumabal from M12I and I'm going to discuss how many atoms are there in the universe. It's no secret that the universe is an extremely vast place that which can observe, aka the known universe, is estimated to span roughly 93 billion light years. That's a pretty impressive number, especially when you consider it's only that we've observed so far. And given the sheer volume of that space, one would expect that the amount of matter contained within would be similarly impressive. But interestingly enough, it is when you look at the matter at the smallest scales that the numbers become the most mind-boggling. For example, it is believed that when 120 to 300 sextillion exists within the observable universe. But looking closer, at the atomic scale, the number gets even more inconceivable. At this level, it is estimated that there are between 10 raised to 78 to 10 raised to 82 atoms in the known observable universe. In layman's terms, that works out between 10 quadrillion vernillion and 100,000 quadrillion vignillon atoms. The second, how much atoms are in the world? A human body weighing 154 pounds or 70 kilograms is comprised of 7 billion atoms. which is 7 followed by 27 zeros. It includes a variety of different types of atoms, only few of which the average person is probably familiar with. Are these atoms? 3 types make up the majority.
Hi, I'm Jaymalene Ann Reyes from Elm 12I, and today I'm going to explain the arrangement of elements in the periodic table. The periodic table of elements arranges all of the known chemical elements in an informative way. Elements are arranged from left to right and top to bottom, and in order of increasing atomic number. The rows are called periods. The period number of an element signifies the highest energy level an electron in that element occupies. The number of electrons in a period increases as one moves down the periodic table. Therefore, as the energy level of an atom increases, the number of the energy sublevels of per energy level increases. Elements that occupy the same column in the periodic table is called group. Groups have identical valence electron configurations and behave in a similar fashion chemically. For example, all elements in the group 18 are called noble gases. Dmitri Mendeleev is considered as the father of the periodic table. He arranged the elements according to both atomic weight and the valence electron. Now, I will teach you how to read the periodic table. First, atomic number. Atomic number is equal to the number of protons in the atom. The number of protons defines what element it is and also determine what chemical behavior of the element. Next, the atomic symbol. The atomic symbol of the element is an abbreviation chosen to represent the element. For example, H in hydrogen. Next, the atomic weight. The atomic weight is the sum of the protons and neutrons in an atom. And that's all.